This is my video clip on research data organization, interpretation, and discussion. So this is Jonalyn M. Tercio, and this is my topic. So methods of data presentation. One of the most important aspects in any statistical investigation is the manner by which the researcher presents the data. So various modes of data presentation. First is textual. Second is tabular. Next is graphical display. So there are a lot of modes of data presentation. So first is textual presentation. From the word text, the data are presented in the form of text, phrases, and paragraphs. Among common among newspaper reports depicting especially the salient of or important findings. So here is an example. Next is the tabular display, a more reliable and effective way of showing relationships or comparisons of data through the use of tables. The tables must be accompanied by a short narrative explanation to make the facts clear and more understandable. So, methods of data presentation example, the following newspaper report presents a tabular data presentation. So this is an example of tabular. So the country are United States, Japan, United Kingdom, Hong Kong, Switzerland, Canada, and Singapore. So these are the peso or the currency of their country. Next is the graphical display. The most effective way of presenting data through the use of statistical graph can easily attract the attention as well as the interest of the reader. The types of graph. So this will be belong on the graphical presentation. So first is bar graph. Uses rectangular bars, the length of which represents the quantity or frequency of each type or category. Next is multiple bar graph. Used when the researcher wants to compare figures on two or more different occurrences. A legend is especially helpful in guiding the viewer in analyzing data. Next is pie chart, used to present quantities that make up a whole. Constructed using percents, and the slices of the pie are drawn in the proportion to the different values of each class, item, group, or category. Next is line chart, useful in showing trends over the period of time. So this is and the frequency table. So one of the data organizations. So definition. Data is in its original form and structure are called raw data. Example, the following data represent the quarterly sales tax receipts in $1,000 submitted to the comptroller of Jimoserville Township for the period ending March 2010 by all 50 business establishments in the locale. So this is the quarterly sales tax. So I will not read this. Then, when the scores are arranged in either ascending or descending magnitude, then such an arrangement is called an array. It is usually helpful to put the raw data in array because it is easy to identify the extreme values or the values where the scores must cluster. When the data are placed into a system wherein they are organized, then these partake the nature of group data. The procedure of organizing data into groups is called the frequency distribution table or the FDT. Example, the following presents a frequency distribution table of the scores of 15 behavioral statistics graduate students. The table shows the frequency, so 20 to 29, there are 5, 30 to 39, 5, or 4 rather, 40 to 49, 3, 50 to 59, 2, 62, 69 is 1. So the total is 15. are the components of the frequency distribution table. So class interval. These are the numbers defining the class. Consist of the end numbers called the class limits, namely the lower limit and the upper limit. Class frequency shows the number of observations. Class boundaries, these are the true class limits. Upper class boundary is defined as the middle value between the upper class limit of the class and the lower limit of the next class. So class size, the difference between the two consecutive upper limits or two consecutive lower limits. So class mark or CM, midpoint or the middle value interval. Next is cumulative frequency. So shows the accumulated frequencies of successive classes. Types of cumulative frequencies greater than or shows the numbers of observation greater than the NCB. Less than shows the number of observation less than UCB, upper class boundary. The following are suggested steps in constructing the frequency table. So determine the number of classes. First approximation, it is suggested to use the Sturge approximation formula. K equals 1 plus 3.32 log n, where K is the approximate number of classes, n is the number of cases. Second is determine the range, where R is the maximum value and minimum value. Determine the approximate classes C using the formula C equals R over K. It is usually convenient to round off C to a whole number. Determine the lowest class interval or the first class. This class should include the minimum value of the data set. For uniformity, let us agree that our purposes, the lower limit of the class interval should be start at the minimum value. Determine the class limits by adding the class size C to the limits of the previous class. Tally the scores and observation failing each other class. So next is the research data interpretation. So this was taken from the slides of Professor A. Balasubramanian, Center for Advanced Studies in Earth Science, University of Missouri, India. All meanings we know depend on the key of interpretation. It is right. This is according to George Eliot. These are the principles of analysis and interpretation. So data are used in behavioral research, means research results from which inferences are drawn. Usually numerical results like scores of tests and statistics such as means, percentages, and correlation coefficients. Analysis means the categorizing, ordering, or manipulating and summarizing of data to obtain answers in research questions. Interpretation takes the results of analysis. So, interpretation is after you have done analyzing the result. So, makes inferences pertinent to the research relation studied and draws conclusion about this relation. Here are the methods of data interpretation. So, first, direct visual observations of raw data. Next is after organizing the data in tables, after making graphical representations, and after calculations using numerical or statistical methods after mathematical modeling. So data is known to be crude information and not knowledge by itself. So this is true. So the sequence from the data to knowledge is from data to information, from information to facts, and finally from facts to knowledge. So facts becomes knowledge when it is used in the successful completion of the decision process. Massive amount of facts are integrated as knowledge. Level of exactness. So this is the level of exactness of statistical model. So from data to information, from information to facts and to knowledge. So level of improvement on decision making. Usefulness and utility of research findings lie in proper interpretation. So interpretation is the basic component in research. So after collecting and analyzing the data, the researcher has to accomplish the task of drawing inferences followed by report writing. So this has to be done very carefully, otherwise misconclusions may be drawn and the whole purpose of the doing research may get vi- vitiated. So it's only through interpretation that the researchers can expose relations and processes that underlie findings. Meaning of interpretation. So interpretation refers to the task of drawing inferences from the collected facts after an analytical or experimental study. In fact, it is a search for broader meaning of research findings. So the task of interpretation has two major aspects. This the effort of to establish continuity in research through linking the results of a given study with those of another, and the establishment of some explanatory concepts. In one sense, interpretation is concerned with the relationship between the collected data, partially overlapping analysis. Interpretation also extends beyond the data of the study to each the results of other research, theory, and hypothesis. So the interpretation is the device. Thus, interpretation is the device through which the factors that seem to explain what has been observed by researcher in the course of the study can be better understood, and it also provides a theoretical conceptions which can serve as a guide for further researches. So why we need interpretation? So interpretation is essential for simple reason that the usefulness and utility of research findings lies in proper interpretation. It is being considered a basic component of research process because of the following reasons. First, through interpretation, that the researcher can well understand the abstract principle that works beneath his findings. Through his through this, he can link up his findings with those of other studies having the same abstract principle and thereby can predict about the concrete world of events. Fresh inquiries can test these predictions later on. This is the continuity in research can be maintained. Okay, interpretation leads to establishment of explanatory concepts that can serve as a guide for future research studies. It opens new avenues of intellectual adventure and stimulates the request for more knowledge. Researcher can be better appreciate only through interpretation what his findings are, what they are, and can make others understand the real significance of his research findings. So, here is the process of interpretation of findings. The interpretation of findings of exploratory research study often results into hypotheses for experimental research, and as such, interpretation is involved in the transition for exploratory to experimental research. Since an exploratory study does not have a hypothesis to start with, the findings of such a study have to be interpreted on post factum basis, in which case the interpretation is technically described as post factum interpretation. So these are the techniques of interpretation. The task of interpretation is not an easy job, right? Rather, it requires a great skill and dexterity on the part of the researcher. Interpretation is an art that one learns through practice and experience. The researcher may, at times, seek the guidance from experts for accomplishing the task of interpretation. The technique of interpretation often involves the following steps. First, the researcher must give reasonable explanation of the relations which he or she has found, and she must interpret the lines of relationship in terms of the underlying processes and must try to find out the thread of uniformity that lies under the surface layer of his diversified research findings. In fact, this is the technique of how generalization should be done and concepts be formulated. Second, extraneous information, if collected during the study, must be considered while interpreting the final results of research study, for it may prove to be a key factor in understanding the problem under consideration. Third, it is advisable before embarking upon final interpretation to consult someone having insight into the study and who is frank and honest and will not hesitate to point out omissions will result in correct interpretation and thus will enhance the utility of research results. Fourth, researcher must accomplish the task of interpretation only after considering all relevant factors affecting the problem to avoid false generalization. He or she must be in no hurry while interpreting results, for quite often, the conclusions, which appear to be all right at the beginning, may not all be accurate. So these are the precautions in interpretation. One should always remember that even if the data are properly collected and analyzed, wrong interpretation would lead to inaccurate conclusions. It is, therefore, absolutely essential that the task of interpretation be accomplished with patience in an impartial manner and also in correct perspective. For correct interpretation, researcher must pay attention to the following points for correct interpretations. First, at the outset, researcher must invariably satisfy himself that A. The data are appropriate, trustworthy, and adequate for drawing inferences. The data reflect good homogeneity, and that the proper analysis has been done through statistical methods. Second, the researcher must remain cautious about the errors that can possibly arise in the process of interpreting results. Errors can arise due to false generalization. Errors can arise due to false generalization and or due to wrong interpretation of statistical measures, such as the application of findings beyond the range of observation, identification of correlation with the causation, and the like. Another major pitfall is the tendency to affirm that definite relationships exist on the basis of confirmation of particular hypotheses. Researcher must remain vigilant. In fact, the positive test result accepting the hypothesis must be interpreted as being in accord with the hypothesis rather than as confirming the validity of the hypothesis. The researcher must remain vigilant about all such things so that false generalization may not take place. He or she should be well equipped with and must know the correct use of statistical measures for drawing inferences concerning his study. That's why we need to have a guidance of an expert. Researcher must always keep in view that the task of interpretation is very much intertwined with analysis and cannot be distinctly separated. As such, he must take the task of interpretation as a special aspect of analysis and accordingly must take all those precautions that one usually observes while going through the process of analysis. Precautions concerning the reliability of data, computational checks, validation, and comparison of the results. Researcher must never lose sight of the fact that this task is not only to make sensitive observation of relevant occurrences that are, but also to identify the disengage the factors that are initially hidden to the eye. This will be enable him to do his job of interpretation on proper lines. Broad generalizations should be avoided as most research is not amenable to it because the coverage may be restricted to a particular time, a particular area, and a particular conditions. Such restrictions, if any, must invariably be specified and the results must be framed within their limits. The researcher must remember that ideally, in the course of research study, there should be constant interaction between initial hypothesis, empirical observation, and theoretical conceptions. It is exactly in this area of interaction between theoretical orientation and empirical observation that opportunities for originality and creativity lie. Researcher must pay special attention to this aspect while engaged in the task of interpretation. Data interpretation methods. Data interpretation may be the most important key in providing or disproving improving or disproving your hypothesis. It is important to select the proper statistical tool to make useful interpretation of data. If you pick an improper data analysis method, your results may be suspect and lack of credibility. Visually scanning the data before doing any statistical analysis of the data you have collected, look closely at the data to determine the best method of organizing it. By visually scanning the data and reorganizing it, you may be able to spot trends or other anomalies that may help in your analysis of the data. In statistics is a science assisting you to make decisions under uncertainties based on some numerical and measurable scales. Decision-making process may be based on data, neither on personal opinion nor or any belief. Okay, why is it statistical data analysis? Okay, data are not information. To determine what statistical data analysis is, one must first define statistics. Statistics is a set of methods that are used to collect, analyze, present, and interpret data. Statistical methods are used in a wide variety of occupations and help people identify, study, and solve many complex problems in the business and economic world. These methods enable decision makers and managers to make informed and better decisions about uncertain. We can think of statistics as a group of computational procedures that allow us to find meaning in numerical data. Descriptive statistics provide a description of what the data look like. They provide a means to describe the points of central tendency. These are the mean, median, mode, and etc. And dispersion, standard deviation, variance, interquartile range, and etc. Inferential statistics allow the researcher to make inferences about populations from smaller samples of the population. Statistics of the sample are used to estimate parameters of the population. A parameter is a constant value representative of the population, such as population mean and standard deviation, while a statistic is any calculation performed on a sample being tested. Inferential statistics also allow the researcher to test their research hypothesis. Some measures used in inferential statistics include the standard error of the mean, estimators, and the p-value. The way that the data is interpreted can have varying effects on the conclusions. Absolute honesty in recording and interpreting data is required to maintain the credibility of research. All the conditions of situation should be considered and that we make inferences in strict accordance with the data obtained. Using statistics to determine relationship is paramount to the success of good research. Using tools such as ANOVA, correlations, Fisher, exact test, regression, and others can predict whether or not your research hypothesis is satisfied. But remember, to select your p-value before you begin your research project. Doing this will add credibility to your research. Another important other important point to remember when doing data analysis is to use parametric statistics instead of non-parametric statistics whenever possible. Remember that parametric statistics relies on the assumptions of normality, which gives greater power than the non-parametric testing. Both parametric and non-parametric statistical tests are used for interpretation. So this is how you're going to interpret qualitative data. Qualitative data interpretation tends to be more subjective in nature and many times can be influenced by researchers' biases. Effort must be put into the data collection process to eliminate bias, including collecting more than one kind of data. Get in many different kinds of perspectives on the events being studied purposely. Look for the contradicting information, acknowledging your biases that relate to your research report. Qualitative data analysis. Qualitative data analysis is time consuming and complex because a lot of data can be created that is both useful and not useful. There is no correct way to analyze qualitative data. So efforts can be made to make your data presentation and interpretation more credible and less biased by using the above methods. Statistics consists of the principles and methods for designing studies, collecting data, presenting and analyzing data, interpreting the results. Statistics has been described as turning data into information and data-based decision making. Data interpretation again, uncovering and explaining trends in the data. The analyzed data can then be interpreted and explained. In general, when scientists interpret data, they attempt to explain the patterns and trends uncovered through analysis, bringing all of their background knowledge, experience, and skills to bear on the question on and relating their data to existing scientific ideas. Given the personal nature of the knowledge they drawn upon, this step can be subjective, but that subjectivity is scrutinized through the peer reviews process. Scientists interpret data based on their background, knowledge, and experiences. Thus, different scientists can interpret the same data in different ways. By publishing their data and techniques they use to analyze and interpret those data, scientists give the community and the opportunity to both review the data and use them in the future research. So here we are going to discuss about the discussion after you have presented your data or organizing your data. Mm, you're going to interpret. So next, after you have interpreted your results, discussion will be followed. So when when you're going to write a discussion, you should start with the objective of the study or the statement of the problem. So start with the objective of your study. So example, the purpose of this research was to test a model to understand whether culture moderated the internal marketing practice and employee satisfaction relationship. Start with or highlighting the study or the purpose of the study. Next, discuss or highlight each hypothesis. Discuss each research problem separately. Separately. Two things that we should not note in this here is first, whether your hypothesis is supported or not. Second is, if it is supported, has been there, practices a previous research that compares to this research. So next is how your results compare to results from the previous research. Why a certain relationship may be significant or insignificant in your research. So these are the example. Next is, what does the significance and insignificance of relationship show in the field of your study? Next is, use the theory. So it is always critical to incorporate the theory that you have utilized to establish the relationship as mean to explain why or why not certain relationship exist. This this is particularly important when there is lack of existing research into particular area of research or the relationships have not been previously established. That's why we need to read a lot of literature. So conclusion is an overall conclusion from your research in light of your objectives. So you can't have a conclusion if you're if you haven't done your data collection, data organization, and interpretation. So once you have your conclusion, once you have your interpreted data, you can now have your conclusion. So that's all. I hope you have learned from my video clip. So that's all for today's. These are the references I have searched to have this presentation. So, thank you and God bless. And stay safe, everyone.